Lessons in Logic, video number 29, and our first video of our third unit on statement logic. First unit was introductory, second unit categorical logic. This is our third unit now on statement logic. And in this video, we want to do a few things to introduce statement logic, and then we want to introduce some important syllogisms and the famous forms method in statement logic. All right. A syllogism is an argument made up of two premises and a conclusion. So far, the only syllogisms we've been interested in have been categorical syllogisms. All cows are mammals, all mammals are animals, so all cows are animals. That's what we call a barbarous syllogism. Never mind that. Now we're doing something different. You can also use the word syllogism in statement logic. And in statement logic, we're interested in arguments who, you know what, let me just start that sentence again. In fact, let me rewind and do some more basic review. In logic, we're interested in strategies for testing arguments to see whether the premises provide good enough support for their conclusion. So in inductive logic, we are interested in strategies to see whether the premises of an argument provide good probabilistic support for their conclusion. In deductive logic, we're interested in strategies to find out if arguments are valid. And an argument is valid when its premises guarantee its conclusion, i.e., it's not possible for the premises to be true and the conclusion false at the same time. An argument is valid depending on whether or not it has the right form or the right pattern, meaning whether it reasons about things in just the right way that it's not possible for the premises to be true and the conclusion false at the same time. In deductive logic, all we're interested in is whether it's possible for premises to be true and the conclusion false at the same time, which depends entirely on the pattern of the argument or the way we're reasoning about things, not the things we're reasoning about, or the form of the argument or the structure of the argument. In categorical logic, the thing we just wrapped up, we break an argument down into its small parts to see if the pattern of the argument is the right kind of pattern for it to be valid. And the small parts we break it down into are the terms of the argument and everything else. Terms are nouns or noun phrases that denote categories. Speaking imprecisely, but closely enough. In categorical logic, we break an argument down into its categories and see if the argument relates the categories in such a way that the premises can't be true and the conclusion falls at the same time. In statement logic, we also break down an argument into its parts, but slightly larger parts. We're interested in the smaller sentences in an argument, or to be a little more precise, in statement logic, we break an argument down into its atomic statements or simple statements. And the simple statements of an argument are those that are not made of any other. So is that enough review? All right, in categorical logic, we study arguments where the fundamental components are terms representing classes or categories, and in proposition logic or statement logic, we study arguments where the fundamental components of the arguments are simple propositions. Proposition and statement are synonymous, and so are the terms compound proposition, and actually that's it. Simple proposition and atomic proposition are the ones that are synonymous, the terms that are synonymous. All right, I'm talking too quickly about too many things. In categorical logic, we look at terms as the fundamental components of an argument. In proposition logic or statement logic, we look at simple propositions as the fundamental components of an argument. A simple proposition is a proposition that is not made up of other smaller propositions. A compound proposition is one that is made of other smaller propositions. So, for example, here's a simple proposition. I like tea. Here's a simple proposition. It is raining. Here's a simple proposition. Biden is president of the US. Here's a simple proposition. The weather is warm today. Here's a simple proposition. Guinea pigs are fuzzy. Classical logic is actually not entirely categorical. Classical logicians did most of their work with categorical logic, doing all that Aristotle stuff, all those categorical syllogisms and all that. That's why the medievals gave us names for the valid syllogistic forms in categorical logic. But classical logic did do some work with statement logic or proposition logic. Now, let's There we go. This is what I wanted to scroll down to. I need to scroll up and give examples of compound propositions and clarify one rookie mistake that I've made. In fact, yes, if I remember correctly, I made this mistake even when I was teaching my first logic class. It was terrible, but it happened, and I want you to avoid my mistakes. Okay, so we are going to, in this video, look at some famous argument forms using this statement logic or propositional logic. But this is the thing I wanted to scroll down to. You'll note I just gave as an example of a simple proposition, guinea pigs are funny, a fuzzy. Well, we could do that one too. That is also a simple proposition. And you'll notice that we are using terms. These are categorical propositions. In fact, they are A-form propositions. They're categorical propositions, universal affirmative. All guinea pigs are fuzzy. All guinea pigs are funny little creatures. These are categorical propositions, but they're simple statements. They're atomic statements. They're propositions not made up of other propositions. So that means that categorical logic and statement logic can't completely be separated. There's still some categorical logic in the background because simple propositions can themselves be described as categorical propositions. In fact, all of these can. I am a person who likes tea. All people who are Mark are people who like tea. All times that are now are times when it is raining. All people who are Biden are people who are president of the USA. All things that are the weather today are things that are warm. All guinea pigs are fuzzy things. All guinea pigs are funny little creatures. These are all, they're all actually a universal affirmative A-form categorical propositions. So you can't ultimately separate them. And that's why if you want to have the ultimate power in testing arguments for validity, you need to learn categorical logic and learn statement logic, and then combine them with something called predicate logic, where we learn to look at the terms and the statements at the same time. We're not ready for that, and I'm not getting to that in this series anyway, as far as I know, unless I come up with some more ambitious plans later. I hope not. I'm tired. Simple proposition, I am tired. What was I saying? Right now, we're just doing statement logic. Right now, we're just looking at arguments by studying their patterns, by paying attention to these simple propositions. But there's still categorical issues right around the corner, and that's why it's good we studied categorical logic, and why ideally we would move up to predicate logic. Who knows, maybe I'll get ambitious later. All right, proposition logic. Let's rewind and finish what I was saying about compound and simple propositions, or compound and atomic propositions. Let me state this explicitly. I think I have already, but let me just state it one more time. Statement and proposition are synonymous. Statement logic and proposition logic are synonymous. Simple proposition and atomic proposition are synonymous. And I may not always be clear on which of these terms I use. I'm trying to stick consistently these days with statement logic, not proposition logic, and with statement rather than proposition. I'll probably try to stick with simple rather than atomic proposition. And now that I've said that, don't be surprised if irony happens and I start sticking with atomic. Now, a proposition that is not made of any other smaller propositions is a simple one. Now, that rookie mistake I mentioned is to take a proposition that's made of one proposition and call it simple or atomic. Example, here's a false proposition, but it is a proposition if I tell you I am not tired, or I do not like tea. So let's keep some of these true. More of these true. I like tea. I guess we'll still have a false one, won't we? I like coffee is an atomic proposition. I do not like coffee is a compound proposition. I like coffee is a simple proposition. I do not like coffee is a compound proposition. Now, why do I say it's a compound proposition? Because it's made of another proposition. A compound proposition is one made of other smaller propositions. So the rookie mistake is to think that compound proposition means proposition made of two or more propositions. Well, every proposition made of two or more propositions is compound. For example, I'm tired and it is raining. That's a compound proposition. It's made of two propositions. The proposition, I am tired, and the proposition, it is raining. So yeah, those are compound propositions. Or if I tell you, I like tea, I like coffee, and I am tired, that's another compound proposition made of three propositions. But A proposition made of just one proposition is still a compound proposition if it's made of a proposition that's different from itself. Now, let's not get into metaphysics and whether things are identical whether things are made of themselves. Let's not talk about that. Maybe I like tea or I like coffee is a proposition made of itself, but I do not like coffee is a proposition made of a proposition that is not itself. I like coffee is a proposition, and I do not like coffee is a proposition made of that other proposition. In other words, negations are compound propositions. They're not simple propositions. A compound proposition could be made of only one proposition if it's a negation. So for all of these simple propositions, there's a denial of them that is a compound proposition. I like tea. I do not like tea. In fact, let's just Control V and negate all of them. I like tea, simple proposition. I don't like tea, compound proposition. I like coffee, simple proposition. I don't like coffee, compound proposition. I am tired, simple proposition. I'm not tired, compound proposition. It is raining, simple proposition. It is not raining, compound proposition. Biden is president of the USA. Biden is not president of the USA, compound proposition. The weather is warm today, simple. The weather is not warm today, compound. Guinea pigs are fuzzy, simple. Guinea pigs are not fuzzy, compound proposition. Guinea pigs are funny little creatures, simple proposition. Guinea pigs are not funny little creatures, compound proposition. And again, the conjunctions, like I am tired and it is raining. Biden is president. Biden is president, and weather is warm. Those are conjunctions. When is this video coming out? Probably in 2023. So this will seem timely at the time, unless Trump is obviously running and DeSantis not. Timely or not, though, is a compound proposition, and it's an or proposition. We call the or propositions disjunctions. Either Biden will win in 2024 or DeSantis will win. Biden will win in 2024, simple proposition. DeSantis will win in 2024, simple proposition. Either Biden will win in 2024 or DeSantis will win, compound proposition. So a compound proposition is a proposition made of other smaller propositions, and it doesn't even have to be two. A denial of a proposition is itself a compound proposition. Thinking it's a simple one is a rookie mistake. Better to avoid it. Let's just do one more. Let's do two more. The if-thens are compound propositions. If the economy continues, let's say inflation. If inflation, I'm recording this in 2022. This video will probably come out in about well, actually a little more than a year. Actually, wow, this video might come out in 2024. I don't know what's on the roster. If inflation continues to be terrible, then I don't know for sure if this is a true proposition. It's certainly a plausible one. Anyway, it's a compound proposition. If inflation continues to be terrible, then Biden will not be president in 2025. Inflation continues to be terrible. Simple proposition, Biden will not be president in 2025. Compound proposition, actually. Biden will be president in 2025. Simple proposition, Biden will not be president in 2025. Compound proposition, inflation continues to be terrible. Simple proposition, if inflation continues to be terrible, then Biden will not be president in 2025. Compound proposition. Let's do a simpler if then. If guinea pigs are cute and fuzzy, then guinea pigs make good pets. That's a complex proposition, compound proposition made of other smaller propositions. And I just said it, complex. Should have thought of that one sooner. No, this is also synonymous. Compound proposition and complex proposition, that's also synonymous. My brain may, as with statement, proposition, simple, atomic, my brain may sometimes switch back and forth between compound and complex, and I may not think to clarify. Try not to get confused. They mean the same thing. Or if there's any subtle distinction, it is way too advanced for this course of study in the basics of statement logic. If guinea pigs are cute and fuzzy, then guinea pigs make good pets. I was going to try one with three. I like tea, and I like noodles, and I am tired. Actually, let's add a fourth one, and I am busy. Yeah, that's a good description of me in the office. Tea, noodles, tired, busy. That's me in the office. All right. I should eat these later. Okay, those are compound propositions. Anyway, let's keep going. Now, let's name some of these propositions. An if-then proposition is what we call a conditional or hypothetical proposition. Note, if it's not already frightfully obvious, some propositions are made of others. Note that we can represent propositions made of others by replacing the propositions they're made out of with capital letters. So we can represent a conditional proposition as if A, then B, where A is the if clause and B is the then clause. A is guinea pigs are cute and fuzzy. B is guinea pigs make good pets. In the compound conditional proposition, if guinea pigs are cute and fuzzy, then guinea pigs make good pets. Now we're using capital letters to represent propositions, not terms. So there's a rookie mistake to avoid. When you're doing categorical logic, never use a capital letter to symbolize a statement. When you're using proposition logic, never use a capital letter to symbolize a term. Also, use a capital letter to symbolize an atomic proposition, not a compound one. Here's a rookie mistake. You could symbolize I don't like coffee with the capital letter C. But you should symbolize I don't like coffee as not C, and symbolize I like coffee as C. So let me think. We can represent propositions made of other propositions by replacing the atomic propositions, the simple propositions of which they're made. Let me fix the grammar here. We can represent a proposition made up of other propositions by representing the simple propositions of which it is made with capital letters. So we can represent conditional proposition as if A, then B. Good, good. And what about this funny one? If inflation continues to be terrible, then Biden will not be president in 2025. We could use B for Biden will be president in 2025, and A for inflation continues to be terrible. Or if we prefer, T or I for inflation, T for terrible. And we could symbolize the argument as if T, then not B. T for inflation continues to be terrible, and B for Biden will be president in 2025. So if inflation continues to be terrible, then Biden will not be president in 2025 is if T, then not B. An antecedent is the if clause of a conditional proposition. Now, the term has been defined for you in this series. Number, what is it, 29, I think, on the Lessons in Logic playlist. If I use the term antecedent and don't pause to define it, you should still know. I've told you. Consequent, that means the then clause of a conditional proposition. So guinea pigs are cute and fuzzy. In this statement, if guinea pigs are cute and fuzzy, then guinea pigs make good pets. Guinea pigs are cute and fuzzy is the antecedent. The consequent is guinea pigs make good pets. In this other one, if inflation continues to be terrible, then Biden will not be president in 2025. Inflation continues to be terrible is the antecedent proposition. Biden will not be president in 2025 is the consequence. The negation of a proposition is its denial, i.e. these are all negations up here. I don't like tea, I don't like coffee, I am not tired. These are negations of the propositions. I do like tea, I like coffee, and I am tired. A disjunction is an either-or proposition, and a disjunct is one of the parts of a disjunction. All right? You know, this may turn up in a later video, so at the risk of redundancy, I'm going to say it now, because it should be said now. A conjunction is a both and proposition, and a conjunct is one of the parts of a conjunction. A conjunct is one of the parts of a conjunction. A conjunction is a both and, a disjunction is an either or, and disjunct is one of its parts. So Here is a complex conjunction. Let's type up a simpler one. I actually don't have tea, so this is not quite true now, but I certainly am tired and I could get tea. So I am tired and I have tea is a complex proposition, a compound proposition made of the propositions I am tired and I have tea. And I am tired is one of its conjuncts. I have tea is the other conjunct, and the whole thing is a conjunction. Either Biden will win in 2024 or DeSantis will win is a disjunction. Biden will win in 2024 is a disjunct, and DeSantis will win is the other disjunct. I'm recording this in 2022. If the news has changed dramatically, just whatever. It's just a proposition. We don't even care if it's true as far as logic class is concerned. Now, we've got all this vocabulary. What do we have so far? In fact, we have a short overview of what is, well, actually a short overview of the different branches of logic, and then a short overview of what is proposition logic, and a short overview of compound versus simple, or complex versus atomic propositions. And then we have these vocabulary terms for different kinds of compound propositions and some special names for their parts. Now let's look at the names of several famous argument forms that are syllogisms in statement logic. The disjunctive syllogism is a valid argument form, meaning that premises can't be true and the conclusion false at the same time. It comes in two basic forms. And yes, they are two different forms. It's either A or B, not A, so B, and either A or B, not B, so A. That is a valid syllogistic form. Find an argument with that form, and it's not possible for the premises to be true and the conclusion false at the same time. I don't like how I have this typed up now, so I'm going to type it this way. And that's much better. Now, technically, if you want to get technical, the convention in logic class is to use a capital letter to represent a very specific atomic proposition. So if you're representing a form, you want to use a different symbol that will represent all propositions, all simple propositions, that is. Actually, no, all propositions. And the standard approach is P and Q capitalized. So let me state that again in hopes that it will clarify things to the occasional student who's seeing Q's and P's and capital letters in the textbook and wonders what on earth is with these lettering. Why are we using this symbolization system at one time, another symbolization system at another time? Well, the two symbolization systems you've seen in this playlist so far, the Lessons in Logic playlist, I think we're in video 29 now, are use capital letters to symbolize terms for categorical logic, and use capital letters to symbolize propositions for statement logic, or statements for statement logic, statements for proposition logic. Propositions for proposition logic all means the same thing. Well, now I'm giving you a different, slightly more refined symbolization system. A capital letter technically symbolizes a very specific, in any particular proposition you want it to symbolize. A and B would symbolize, depending on what argument you're working with and what you said it symbolizes, and it only works for within the scope of your symbolization system. Now, when you're doing your homework, you're given an argument, and you'll use A to symbolize a simple proposition in lesson one. When you're doing a lesson in your homework, you'll use a capital A to symbolize an atomic proposition in argument number one from your homework, and B to symbolize another atomic proposition, or whatever symbolization system you use. Which capital letter you use doesn't really matter. But while you're doing exercise number one in your homework, A stands for that atomic proposition. And when you move to exercise number two, A can stand for another one. But whenever you're using a capital letter, it stands for one particular atomic proposition. But P and Q highlighted in lowercase, like I have here on the screen now, that is the universal simple system for symbolizing any proposition. And when you need more, you use R, S, and T if you need them. Okay, so let's probably stick with this throughout. I'll adjust my notes accordingly if my brain holds up. Let's see, how do I type this up? Ah, yes, that was it. There we go. All right, so disjunctive syllogism is a valid argument form that has these varieties. Basically, it's a disjunction, and you deny one of the disjuncts in the second premise. You set up a disjunction in the first premise, deny one of the disjuncts in the second premise, leaving you with the other disjunct is true. And it's not possible for the premises to be true and the conclusion false at the same time. It's not possible for either of these things to be true. Sorry, it's not possible for it to be true that one of these things is true and one of them be false and the other not be true. See, you can't have X or Y true and Y false and none of X true. If X and Y are both false, then X or Y is also false. In other words, it's possible for the either P or Q proposition in a disjunctive syllogism to be false, but it's not possible for the premises to be true and the conclusion false at the same time. All right. Now in logic, we normally consider the word or to be used inclusively. So we assume that it's possible for both disjuncts to be true. So argument forms are invalid and should not be confused with disjunctive syllogism if they look like this, either P or Q, P, so not Q, either P or Q, Q, so not P. Now, sometimes the word or is used exclusively, such that in a true disjunction, it will not be the case that both disjuncts are true. For example, and here's one where a proposition seems terribly out of date. I must have made an original version of these notes quite some time ago. Either Mitt Romney or Barack Obama will win the US presidential election in 2012. Well, they weren't both going to win, were they? So if you come across an argument using or in this exclusive way, my advice, which probably came directly from a logic textbook, but is very good advice, and I'm adopting it as my own. My advice is just treat it as an enthymeme. So the argument, either Romney or Obama will win in 2012, Romney will not win, so Obama will win, has an unstated premise. The unstated premise is it won't be both. So the argument turns out to be not a disjunctive syllogism. I don't even know what we would call it. It would have this form. Either P or Q, not both P and Q. P, so not Q. Or either P or Q, not both P and Q. Q, so not P. Now, the reason I'm giving two forms for each argument pattern is just that the order doesn't actually matter. If you phrase one disjunct first and the other disjunct second or vice versa, it really doesn't make any difference to the logic. Nevertheless, these are the patterns of arguments as they occur. People phrase them in either order. They mention Biden first, they mention DeSantis first. It doesn't matter. But if you want to keep track of things, be prepared to see either P or Q, not P, so Q, or either P or Q, not Q, so P. And that's the valid disjunctive syllogism form. Either P or Q, P, so not Q, either P or Q, Q, so not P, which is invalid because inclusivity of the use, inclusivity of the word or means it's possible for premises to be true and conclusion false at the same time. Either P or Q, P, so not Q. I don't know, either Senator Smith is a jerk or Senator Jones is a jerk. Senator Smith is a jerk, so Senator Jones is not a jerk. You could easily have both premises true and the conclusion false at the same time. Oh, I've seen names for this, and I like the name. It's not a very fun name to say. It's affirming a disjunct. Because what happens in the second premise is we affirm one of the disjunctions. What happens in the second premise is we affirm one of the disjuncts. So that's a name for this invalid form if you want. But keep in mind that there is a valid form, and you might sometimes mistake a valid argument for an invalid argument if you don't realize that it's an enthymeme, meaning an argument with an unstated premise. The unstated premise being not both. So what about this form? Either P or Q, not both, P therefore not Q, or either P or Q, not both, Q therefore not P. What's the name of this kind of argument? It's not really disjunctive syllogism. It's not affirming a disjunct exactly. It's a different form. I could tell you a name that is sometimes used for this form and give you one, but I can't think of one I've heard before. Or I could give you a name. Or I could just say, I don't know that it has a name, but it wouldn't be a bad idea to give it one. You could call it Larry. Name is sometimes used for this form. And I still can't come up with a name. Pause the video recording to think for a moment. I still can't come up with a name. So I can't fill in a name there. I guess technically it's not a syllogism anymore once you add in that extra premise. I can describe it, but I can't name it. Fermion disjunct on that last one is a short description of what happens in the second premise. So this one would be something like a Fermion disjunct after an additional premise that renders the OR exclusive. So it's a terrible description. I can't shorten it to a name. I suppose we'll go on to pure hypothetical syllogism in a moment. I'm going to pause the recording again and straighten out text messages from my wife. I'm caught up on text messages. Let's go to pure hypothetical syllogism. Now, I've often heard this referred to as just hypothetical syllogism. That's the name I'll probably use myself. Let's some brackets around that. And this will sometimes be abbreviated HS, and disjunctive syllogism will sometimes be abbreviated DS. That may come up later. It may be important if I do a subunit on proofing. I hope to do truth tables in this unit on statement logic. I'm not sure if I want to do proofing. Well, let's make it more generic. P, Q, and R. Okay, if P then Q, if Q then R, so if P then R, where again, this is a pattern that refers to any argument that has this form. Whereas technically, if I kept it with capital letters, I'm not referring to any argument that has this form. I'm referring to a specific argument. If P then Q, if Q then R, if P then R, lowercase and italicized those symbols, if P then Q, if Q then R, so if P then R. That is a valid syllogism. Any argument having this form is valid. Let's see if I've explicitly stated in our earlier notes. Let me scroll up and make sure I've explicitly stated what's valid, what's not. A valid argument form, disjunctive syllogism, invalid form, Fermion disjunct, and then this valid form. The unnamed valid form. And pure hypothetical syllogism is a valid argument form with two conditional propositions where the, three conditional propositions. The hypothetical syllogism has three conditional propositions, three hypothetical propositions, and two in the premises. And the conclusion uses the antecedent of the first one and the consequent of the second one. And the consequent of the first one is itself the antecedent of the second one. If P then Q, if Q then R, therefore if P then R. You know what? Let me give another concrete example of this. What's an argument like this? If inflation continues to be terrible, then Biden will be very unpopular in 2024. If Biden will be very unpopular in 2024, then probably DeSantis will be the next American president. Therefore, if inflation continues to be terrible, then DeSantis will probably be the next American president. That's a hypothetical syllogism. It's valid. It's not possible for the premises to be true and the conclusion falls at the same time. Now, using again some terminology, some text, I probably won't use it much myself. There are four syllogisms we can classify as mixed hypothetical syllogisms, meaning they use only one conditional proposition in their premises. And these have special names. And we could have done a whole video on just them. It might have been a good idea if we did. But I'm going over these things a little more systematically here. This is the modus ponens argument form. If P then Q, P therefore Q. And now here is the modus tollens argument form. If P then Q, not Q, so not P. Those are valid forms. It's not possible for the premises to be true and the conclusion false at the same time. But now, let me quickly fill in the forms here. And clarify that there are related forms that are invalid. Modus ponens is valid if P then Q, P therefore Q. Modus tollens is valid if P then Q, not Q, so not P. To fill in some concrete examples, I'm using my standard example. Shout out to Mark Sadler, my logic teacher in undergrad. I think he used this example. If it is raining, then the grass is wet. It is raining, therefore the grass is wet. Valid argument. If it's raining, then the grass is wet. It's not raining, so the grass is not wet. Whoa, bad argument, bad argument. If it's raining, then the grass is wet. It's raining, so the grass is wet. Modus ponens, valid. Now modus tollens, if it's raining, then the grass is wet. The grass is not wet, so it's not raining. Modus tollens, valid form. But now the closely related invalid forms, we can call denying the antecedent and affirming the consequent. If P, then Q, not P, so not Q. Or if it's raining, then the grass is wet. It's not raining, so the grass is not wet. If it's raining, then the grass is wet. The grass is wet, therefore it's raining. Now you can see how it's possible for the premises to be true and the conclusion false at the same time. When Q is true and P is not true, when the, what did I say? When Q is true and P is not true, you can have true premises and a false conclusion. When the if clause, when the if statement, the antecedent of that first premise is false and the consequent true, your premises can be true and your conclusion false. It can be true that if it's raining, then the grass is wet, and yet true that it's not raining and the grass is still wet, and that makes both of these things invalid forms. So if the grass is wet because someone was washing a car right next to the grass, or in fact it was raining earlier and it stopped raining, or the grass is just dewy and wet in the morning, these things happen. So modus tollens and modus ponens are valid forms, but these closely related forms, denying the antecedent and affirming the consequent, are invalid forms. And note where these arguments get their names from. They get their names from what happens in the second premise. Each of them gives an if-then premise, and then it either affirms or denies either the consequent or the antecedent. If it affirms the antecedent, we call it the way of taking, placing, and that's the Latin modus ponens. Modus way, modus, I guess would be better Latin pronunciation. Modus ponens, or something like that. Ponens, which looks like to me like what is a present participle from pano, I believe, which probably means something about place or put. Not a Latin vocabulary word I keep in my head most of the time, though there are other Latin words there. Tolle lege is an Augustan line, so this is easier to find in my head. This means the way of taking, i.e. the way of removing. Modus ponens is the way of placing. Modus tollens is the way of removing. So for modus ponens, we have an if-then statement, and then we place the if in the second premise, and then the then statement follows. Modus tollens, we have an if-then statement, and we take away the then part in the second premise, and then it follows that the if part is not true either. In denying the antecedent, we make the mistake of taking away the wrong thing, and in affirming the consequent, we make the mistake of placing the wrong thing. Or if all that got confusing, these are 4 argument forms. 2 are valid, 2 are invalid. The valid ones, of course, have Latin names. The invalid ones, we just have names that describe what happens in the second premise. But if you want to know, the Latin names also describe something that happens in the second premise. And here's a chart that can help. And gee, I hope this is legible. This is something I worked up on Microsoft Paint, it looks like a long time ago. Each of these has a conditional hypothetical premise, and then it either affirms or denies something. What it affirms or denies is either the antecedent or the consequent. And if the second premise affirms an antecedent or denies a consequent, then it's valid. If it affirms a consequent or denies an antecedent, it's invalid. Where with my color coding system here, red is bad and blue is good. No political commentary intended. All right. Are we almost done? Wow, this is going to be a long video. Maybe it'll save us more videos later. The famous forms method. So now let's make sure we're clear on what's been happening so far in this video. We've reviewed what are the different branches of logic. We've reviewed what is proposition logic or statement logic. We've learned that there are such things as simple propositions or atomic propositions that are not made of any others. We've learned that there are such things as compound propositions which are made of others, and actually a compound proposition can be made of just one other proposition, which is the case with the negation. I don't like tea is made of the proposition I do like tea, and it denies it. So it's a compound proposition made of just one other proposition, but I like tea is a simple proposition not made of any other. All right. And then we've looked at some special terms for different kinds of compound propositions and for their parts. And then we've looked at one famous valid form, which is the really important one. But while we were talking about it, we also looked at a closely related invalid form, and then another form that's actually valid and somewhat closely related, whatever this one that doesn't seem to have a name. Then we did pure hypothetical syllogism, another valid form. So two major valid forms you want to keep track of. And along the way, one valid form it's useful to keep track of, and one invalid form it's quite useful to keep track of. But two really important valid forms, and then two more valid forms, and then two invalid forms. So we're really trying to keep track of disjunctive syllogism valid form, hypothetical syllogism valid form, modus ponens valid form, modus tollens valid form, and then denying the antecedent, affirming the consequent invalid form. Any argument that has this form is going to be invalid. One of these forms, denying the antecedent, affirming the consequent. Any argument that has the modus ponens form or modus tollens form is going to be valid. Any argument with the disjunctive syllogism form will be valid. Any argument with the hypothetical syllogism form will be valid. So if you can find an argument that has one of those four valid forms, one of these two invalid forms, you can know whether it's valid or invalid. So the famous forms method is quite simple. I'm just going to delete, since I've gone over it quite enough, and even in this very video, some of these notes. Actually, I'll keep it up. You can read it on your own time for your own edification and review. Talk to me in comments on the video if you're having trouble finding it, figuring out what it all means. The method is the famous forms method, and it's quite simple. Identify the form of the argument by using capital letters to represent propositions. Rewrite the argument in capital letters so you can see the generic form. Identify any famous forms and evaluate for validity. If it's one of the four valid ones, say this is a hypothetical syllogism, and therefore it's valid. If it's modus ponens, say this is a modus ponens argument, therefore it's valid. If it's denying the antecedent or affirming the consequent, say this is one of those famous invalid forms, therefore it's invalid. Or maybe we should say these are infamous forms, if you like. So this argument will work on any argument that has one of these famous forms. Now let me first refine our method slightly. I'm going to say this: underlining and writing in superscript capital letters is usually a helpful step, but it's not the most important thing. The most important thing is use a scheme of abbreviation. And when I say that, I mean, like I keep saying, first, define some capital letter symbols for the atomic statements in the argument. Define some capital letter symbols for all of the atomic statements. in the argument. And then rewrite the argument using these symbols. And let's illustrate. And that gives us a two-step process, but technically the scheme of abbreviation also has two steps. So this is a useful step, but it's not entirely necessary. The real first step is just identify the form of the argument using capital letters to represent propositions. And I recommend you always do this with a good scheme of abbreviation, which means first, define your capital letter symbols for each atomic statement in the argument and rewrite the argument second using those symbols. So for the argument, if it's raining, then the ground is wet, so it is raining. A can be it is raining. B can be the ground is wet. And the argument symbolized using that system is if A, then B, B, so A. So now you just have to identify any famous forms and evaluate for validity. What famous form are we dealing with here? Well, if you're thinking, I thought the famous form had P and Q. Where's P and Q? I don't get it. All I see is A and B. You have to learn to recognize P's and Q's. P's and Q's are just symbols, and they're universal symbols. They symbolize anything. They symbolize any atomic proposition. Actually, they symbolize any proposition they need to. So if it helps, you could always rewrite it. Right, A is P, B is Q, and then it should be quite obvious. This is this is an affirming the consequent argument form. If it's raining, then the ground is wet, so it's raining, where A equals it is raining and B equals the ground is wet. The argument is if A, then B, B, therefore A. But ideally, you don't need to switch around P's and Q's. You just need to recognize that this is the same pattern, and it shouldn't be hard. I think very few people have any difficulty with this. If you do, that's okay. Keep at it. Don't give up or anything. But it's fairly simple. P and Q are just symbols. They symbolize any statement they need to. If P, then Q, Q therefore P, is the same pattern as if A, then B, B therefore A. That's it. You have an argument pattern here. If A, then B, B therefore A. You have an argument pattern you're looking for. If P, then Q, Q therefore P, and it's denying the antecedent. So you name the argument, you identified the argument as a denying the antecedent form. Identify that it's a denying the antecedent form, and you state that it's invalid because it's got an invalid form, and that's it. Although technically, like I've said a few times, every argument has at least one invalid form. Premise, conclusion is an invalid form, but this argument has a specific form that's invalid. And this is a method that will work on any argument that has one of these famous forms. Now let's practice with the scheme of abbreviation. I've got two here, and I hope we can do them more quickly and wrap up this video. Once again, this is a method that tests arguments for validity using statement logic, and it will work on any argument that has one of the famous forms. Now, I should also mention this, and I sure hope this comes up in a subsequent video, maybe the very next one. If my brain holds up, I'll check my notes. But there are a lot of famous forms. The thing about the famous forms method is the more famous forms you memorize, and usually you'll just have to memorize them. You'll just have to memorize this pattern. You'll have to memorize this pattern. You'll have to memorize this pattern, and I hope these patterns too. These really should be memorized. The more forms you have, the more you have to memorize, but also the more arguments you can use them on. So there's always a balance between a balance a logic teacher or someone writing a logic textbook has to deal with. The teacher, the textbook author has to ask, Do I give them only 5 famous forms and they're much easier to keep track of, but they can't use them on that many arguments? Do I give them something like 15 famous forms and they can use them on lots of arguments, but it's too many for them to keep track of? Or do I settle somewhere in the middle? And is the best middle ground more like 10 or more like 7 or more like 8? Here I've given you 6 famous forms, I think. Disjunctive syllogism, hypothetical syllogism, and then modus ponens, modus tollens, and the antecedent affirming the consequent. So I've given you 6 so far. In another video, I need to give you more. 6, I think, is too few. I think a better number is somewhere between 8 and 12. I hope to give you at least 2 more in a subsequent video, and I'll try to check my notes and make sure they're on my agenda. I think it's perfectly reasonable to include that affirming a disjunct invalid form as one of our famous forms as well. All right, so let's practice with the scheme of abbreviation. Here's some argument roughly inspired by the book of Acts and something Paul says. Paul says something about if anyone is in Christ, he's a new creation. So if the sons of Sceva are in Christ, then they are new creations. The sons of Sceva, as we recall from an anecdote in the book of Acts, are not new creations. Therefore, the sons of Sceva are not in Christ. If you don't know or care what we're talking about, it doesn't matter. Once again, whether the premises are true, the conclusion true, or whatever, even what they're talking about doesn't matter to logic. Let's see if it's a good argument. First, give a key, give a legend, give a scheme of abbreviation. Let's say S for na, C for the sons of Sceva are in Christ, and N for I have to be really tired. I'm having a hard time typing a simple sentence. Let's use C for the sons of Sceva are in Christ and N for the sons of Sceva are new creations. So the argument pattern is if S then, no, if C then N, if the sons of Sceva are in Christ, then the sons of Sceva are new creation. The sons of Sceva are not new creations, not N. Therefore, not C. Therefore, the sons of Sceva are not in Christ. So what argument pattern is this? If it helps, you can just switch the first capital letter you've got for lowercase p. The next one for lowercase q. If p, then q, not q, therefore not p. It's a modus tollens. But I don't think it's necessary to do that switching. Just recognize if p, then q, not q, therefore not p. If c, then n, not n, therefore not c. It's the same pattern. This is a modus tollens. So, whether the premises are true or the conclusion true, whether the premise or conclusion, whether a premise or conclusion is false, we don't necessarily know. We don't even care. But at least not as far as logic class is concerned. In theology class, maybe it matters. But this is still a valid argument because it's not possible for the premises to be true and the conclusion false at the same time. Whether the conclusion is true, I will not say at this time. I will say, if that conclusion is false, one of the premises is false because this is a valid argument. Now, Star Trek. Either original Star Trek is the best sci-fi or Stranger Things is the best sci-fi. I don't even know what capital letters I want to use here. They both start with S, both have a T in the next one, so I could say O for original. How about N? N for Netflix. Which symbols you use doesn't matter, but I'll use O for original Star Trek. Is the best sci-fi. And I'll use N for Stranger Things is the best sci-fi. So now the argument is either N or O. Or is it either O or N? The argument is either original Star Trek is the best sci-fi or Stranger Things is the best sci-fi. Stranger Things is certainly not the best sci-fi, so Star Trek is the best. And what that means in a more orderly fashion, symbolized is original Star Trek brain froze, rewind. The argument is either original Star Trek is the best sci-fi or Stranger Things is the best sci-fi. Stranger Things is certainly not the best sci-fi, so Star Trek is the best. The argument is either O or N, not N, so O, where O is original Star Trek is the best sci-fi, N is Stranger Things is the best sci-fi, and there we go. That's the argument, and this should look familiar. This is a disjunctive syllogism form. It's another valid argument. That's how the famous forms method works. So now you go. Now you know, and now you can go. Thank you for watching. I am at last finished with this intro to the famous forms method and statement logic generally.